Hey there, let's take a look at carbon in nature. Biological carbon. Carbon in the food chain. Land-based plants sequester carbon through photosynthesis. Consumers and other organisms then return this carbon to the atmosphere through respiration. So let's look at terrestrial primary producers. Primary producers, usually plants, are the first organisms in the food chain. Primary producers can make their own energy from sunlight and carbon dioxide through photosynthesis. Photosynthesis is the process where green plants sequester carbon dioxide through chloroplasts in their leaves to produce energy. Respiration. All living organisms respire and contain carbon. By respiring, organisms release carbon dioxide into the atmosphere. Consumers. Consumer organisms eat other organisms below them in the food chain. Primary consumers are the first organisms to eat plants, for example bugs, beetles, and herbivores like rabbits. Primary consumers then return the carbon to the atmosphere, the carbon that the primary producers sequestered back into the atmosphere through the process of respiration. Decomposers. Biological decomposers consume dead organic matter and return the carbon to the atmosphere through respiration. So, let's quickly recap that. All living organisms contain carbon, and through the process of what, living organisms release carbon dioxide into the atmosphere. I'll give you a clue. That was me breathing. So it's through the process of respiration. Biological decomposers consume already dead matter and return the carbon to the atmosphere through, you guessed it, respiration. Now let's take a look at sequestration by phytoplankton. The oceans provide a biological carbon pump. Atmospheric carbon dissolves in the oceans where it can be transformed into terrestrial carbon, so on the ground and the earth, or biological carbon before returning to the atmosphere. Photosynthesis in surface waters. Phytoplankton takes carbon dioxide out of the atmosphere through the process of photosynthesis. All of these organisms sequester, meaning take up, carbon dioxide. They build their shells from calcium carbonate. This transforms the carbon in the atmosphere into biological carbon. These organisms are consumed by other organisms like zooplankton. All of these consumer organisms will respire, returning some of the carbon to the atmosphere in the process. Carbonate shells sink. When phytoplankton and other aquatic organisms die, they sink to the ocean floor. Here these organisms can accumulate as sediment. Eventually they can be transformed into sedimentary rock. They can also be decomposed, which means broken down, by bacteria, which can return carbon to the ocean in the form of dissolved organic carbon. Carbonate pump. This whole process of carbon entering and moving around the ocean is referred to as the carbonate pump. Without oceans acting as a store for carbon, levels of atmospheric carbon dioxide concentration will be significantly higher. The Thermohaline Circulation. The Thermohaline Circulation refers to the global movement of water. Cold water sinks to the bottom of the ocean, while warm water rises to the surface, moving towards cooler water. This process is the reason for the UK's relative warmth in comparison to other locations at the same latitude. Warm Caribbean water passes the UK as it moves northward towards the poles. Slight changes in temperature can change the operation of both the thermohaline circulation and the carbonate pump. Let's just recap that quickly. Photosynthesis by phytoplankton. Phytoplankton takes carbon dioxide out of the atmosphere through the process of photosynthesis. As these organisms sequester, meaning take up, carbon dioxide, they build their shells from calcium carbonate. This transforms the carbon in the atmosphere into biological carbon. The thermohaline circulation refers to the global movement of water. Cold water sinks to the bottom of the ocean, while warm water rises to the surface. Now let's take a look at dead organic matter. Dead organic matter found in the ground or in the soils still contains biological carbon. Different landscapes retain biological carbon in different ways. Soils. Dead organic matter found in the ground or in the soil still contains biological carbon. The biological carbon can be returned to the atmosphere when decomposed by biological decomposers. The rate at which biological carbon is returned to the atmosphere is dependent on temperature and climate. Human activities such as deforestation and land use change can speed up this process though. Mangroves. Mangroves are found at tropical coastlines and sequester 1.5 metric tons of carbon per hectare per year. Mangrove soils consist of layers of litter, humus, and peat, which contain over 10% carbon. Due to being submerged beneath a tidal water twice a day, the soils are anaerobic, meaning without oxygen. Biological decomposers cannot survive without oxygen, so the breakdown of biological material takes a lot longer. Tundra soils. Tundra regions of the world have permanently low temperatures. The soil contains ancient carbon, which is permanently frozen, stopping the microbe activity that decays the material. The microbe activity only happens once the surface layer thaws. Tundra is a massive carbon store, holding carbon for hundreds of thousands of years. So which of the following regions is the biggest carbon store? Is it the tundra, the desert, savanna, or marshland? The correct answer is the tundra. Quickly recap mangroves. They're found at tropical coastlines, sequester 1.5 metric tons of carbon per hectare per year, consist of layers of litter, humus, heat, and peat, which contain over 10% carbon. And because they submerge beneath tidal water twice a day, the soils are anaerobic. What do we call the process of carbon entering and moving around the ocean? We call this the carbonate pump. The rate at which biological carbon is returned to the atmosphere is dependent on which factors? Is it temperature and climate? And quickly recap mangroves one more time. Their soils are anaerobic. They sequester 1.5 metric tons of carbon per hectare per year. The soils are submerged in tidal water twice a day, and the soils consist of litter, humus, and peat.